Welcome to the video about the extra exercises. So most of the exercises which you will find on Teams have also answers you can find on Teams, but some of them don't have any answers, and those exercises will be discussed in these videos. Okay, let's start with the first lesson, and that would be exercise 1.5. And the question is, which of the following sets are equal? So let's look at the first one. We need to figure out what is the content of A. And then we have to go back to our high school knowledge. And so we have to figure out for watch X, this statement will give us a true answer. Okay, so if we look back at high school, then it would give us X minus 3 times X minus 1 being 0. And so x times x is x squared, minus 3x minus 1x will give us minus 4x, and minus 3 times minus 1 gives us plus 1. So the solution is that the set A contains the elements 1 and 3. Okay, then set B, we have x squared minus 3x plus 2 being 0. So that means we have x minus 2 times x minus 1 being 0. So that will give us set B being 1 and 2. Then C, x smaller than 3 and being part of the natural numbers. So this would give us the set 1, 2. And remember, 0 is not an element of n. Then D, they need to be odd and smaller than 5. So that would be 1 and 3. Okay, and the other ones are just given. And then just note that F, for instance, has 2 1s in it. So F is 1, 2. And the same applies for H, 2 1s in it. So that's identical with 1, 3. So which of the following sets are equal? So equal, so that means that A is equal to set D, is equal to set G, and equal to set H. And then B is equal with C, equal with E, and equal with F. Okay, that was doable. Let's look at the next exercise. So now we have a set P, a set Q, and a set R. Question, draw a Venn diagram showing these sets. So we have a universe, and I don't know what the total universe is. So that could be the natural numbers or Z. They didn't give us that. And then we have 3 sets, 3, 6, 1, 2, 3, 4, 5, 6, 8, and 3, 4, 8. And if we just first look at it, then you will see that 3 is part of all of them. So that is one central number. Then we have the number 6, which is in P as well as in Q. So this is P. And then let's make Q blue. That also contains 3 and 6, but also the numbers 1, 4, 8, 5. Yeah, and you see that I'm putting 4 and 8 a little bit close to the 3 because I'm already looking at this set R, which contains 3, 4, 8. And so the set Q, let's make it blue, is this set, and the set R contains 3, 4, 8, so that's this set. Okay, so the red one is R, the black one is P, and the blue one is Q. Which of the sets P, Q, and R are proper sets, subset of other sets? Okay, well, if we look at the black one, that's in the central, and it's completely surrounded with the blue one, and there are elements outside P which are in Q. So we can say that P is a proper subset of Q. And so P is part of Q, and there are elements outside P which are in Q. Okay, and also the red one is completely inside Q. So R is also a proper subset of Q, because also elements outside are inside Q. Okay, then C, P and R are disjoint sets. Is that true or false? Well, if we remember what disjoint means, is that we need to be able to draw the set completely separate from each other. Well, that's not the case. We have element 3, which is as well in P as in R. So this thing is false. Then for the logic part, we have P being a proposition, Peter can speak Dutch. And Q is the proposition, Peter can speak English. Okay, and they want us to write down in a mathematical way, Peter can speak Dutch, but he cannot speak English. So, Peter can speak Dutch, P, but he cannot speak English. So that's an and he cannot speak English, not Q. B, Peter can speak Dutch, or Peter can speak English. So P or Q. They didn't say it's an exclusive one, so it's just a simple or. So it may be that he can speak both languages. C, it is not true that Peter can speak Dutch and Peter can speak English. So not P and Q. That's it. Then let's look at exercise 1.10. Make a truth table. And they've given us 2 propositions only, PQ. So I need to make a truth table with 4 combinations. So P1100, Q1010. Okay, then the first one, let's do P and Q. So that would give us a 1, 0, 0, 0. Then the next one, not P or not Q. So let's first have a look at not P. So that's 0, 0, 1, 1. Then have a look at not Q. The 0, 1, 0, 1. And then the combination not P or not Q. That would give us 0, 1, 1, 1. Okay, then the last one. And then we have to combine the P and Q with the not P or not Q. So we call it 1 and 2. So 1 or 2. That would give us 0, 1, 1, 1, 1. Ah, that's nice. Quite complicated statement, complicated proposition, and it always gives us true. And hopefully we remember that this means that the proposition is a tautology. Okay, those were the exercises of lesson 1.